Hello, in this video we shall discuss about the .NET internal topic, finalization. Actually, there are many concepts involved with finalization, so we shall split our discussions into multiple parts. In the first one, we shall see what is the purpose of implementing finalize method on a .NET class. And the next one, we shall see how to implement what is the effective way to implement the finalize method using a pattern. Along with the theory lines, we will also show a debugging demo to show finalization happening on a .NET application. We will print the finalization queue and the f-reachable queue using WinDBG commands. So let's start our discussions. First of all, let's see what is the purpose of implementing the finalize method. Consider a case, a .NET class has some unmanaged data members. We know that a garbage collector can collect managed resources, but it doesn't have the ability to release unmanaged members. So it becomes the programmer's responsibility to release the unmanaged data members of a class. So during those times, he needs to implement the finalize method. So finalize method is a place to release the unmanaged members. But if the class has only managed resources, programmer need not implement the finalize method for his class. To explain the finalize method with more clarity, I am taking you into two class declarations. But before going here, one more thing needs to be noted. In C#, the finalize method is never implemented directly. In fact, it is implicitly implemented within a destructor. But for a VB.NET, there is a direct method finalize. Now, let's discuss our two class declarations. The first one is smartphone, which has all the components are digital, like digital keypad and digital screen. So symbolically, let's consider that all its data members are managed ones. So this qualifies the smartphone as a fully managed class. A GC knows its best how to destruct a fully managed object and its data members. So we need not implement a destructor for this class since this class doesn't have any unmanaged data member. From here, let's take our attention into a next class declaration, hybrid phone. It has some managed data members like digital screen. But consider its keypad has been built from a previous technology like QWERTY keypad. Observe, this is an unmanaged data member. The inptr data member is a pointer to locate the unmanaged memory from the managed world. So let's see a code snippet how it allocates data. Here in the object constructor, 1 kilobyte of the unmanaged memory is been allocated to this inptr member. Everything is fine up to this point, but the real problem starts during the object destruction. We now know that this hybrid phone is not a fully managed one. It has some managed data members, but it also contains an unmanaged data member. So when GC picks the object for deletion, it knows how to clean the managed data members, but GC doesn't have any idea how to release the unmanaged memory pointed by this member. Effectively, GC can only partially clean the object and the unmanaged memory becomes a leak. In order to avoid such a circumstances, it is the programmer's responsibility to release the unmanaged memory in the destructor. That's what is happening here. Still, one question remains. Who can release the unmanaged memory written in the destructor? We know that GC cannot do that because it can release only managed resources. To answer this, let me take to the next slide. So our question was, who can release the unmanaged resources declared in the destructor? There is a dedicated thread in every .NET application which is called the finalizer thread that is responsible to execute the finalize method or destructor implemented on every object. It cleans the unmanaged resources. Actually, this gives us a chance to ask another important question. How does the finalizer thread understand a .NET object has implemented its finalize method or destructor? Then only the thread can call its finalize method, right? The answer is every .NET object that has a destructor is registered in a queue called finalization queue. The impact of this feature is that any object that is referred or registered on the finalization queue will not be picked by the garbage collector on its first attempt. In fact, the GC will move this object from the finalization queue to another internal queue called F-reachable queue. So these objects are called finalization survivors because they survive one GC attempt. There are much more things to be covered on this topic. We have to discuss a pattern, how effectively we can implement the finalize method on a .NET class. And we have to elaborately discuss about these queues. But in this session, we will do a small debugging demo to show the finalization object, the object's place in the finalization queue, and the finalization survivors. So let's do a demo right now.